This is Unit 5, Lesson 4, Video 1. We're going to be looking at systems of linear inequalities. So last unit we graphed inequalities on a graph, but now we're doing a system, which is two or more linear inequalities together. So we're going to have two lines on the same graph. So if you look, this first line here, that's a solid line. And this, well, it's actually the second line. This is this inequality. And the shading was above. For this dashed line, this is the equation here. And the shading was above that line as well. Well, my answer, my solution, then is here where the shading overlaps. So this is considered the solution. That means any ordered pair inside this overlapping shaded region is a solution to your inequalities, to your system. It's true for both. Okay. So let's just see, is the given ordered pair a solution of the system of inequalities? So I want to know, does this ordered pair, would this fall in the overlapping region? Well, what I do to check is I just plug them in for x and y and see if they're true. Okay, so I have this inequality, the top one, so 7 greater than negative 2 plus 5. Okay, so we would type that in our calculator or calculate that. Is 7 greater than 3? Yes. Okay, check the second inequality. That's 0. Is 7 less than 0? No. So is this ordered pair a solution? No. It has to be true for both. So let's check the next one. Negative 2 less than or equal to 2 times negative 2 plus 7. Is negative 2 less than or equal to 3? Yes, it's less than. So we're good. Okay. Is negative 2, oh, well, I plugged the wrong thing in. It was true, but I had done that wrong. So negative 2 less than or equal to 2 times 3 plus 7. So you should be plugging 3 in for x. It's still true because that's 13, and negative 2 is definitely less than 13. Okay. 4 times 3 plus 2, less than or equal to. And that is negative 10. So, is negative 2 less than or equal to negative 10? No, that is false. So again, my answer is no. Okay. Let's practice graphing now. Alright, well, I noticed that my first inequality is in slope-intercept form, so that makes that pretty easy. My slope is 2, which is 2 over 1, and my y-intercept is 0, negative 5. So, let me put our scale. I'll start at negative 5 on the y, and then my slope is 2, so up to right 1. Since this is not an equal to, I need a dashed line. And then I want to shade on the side of the line that's above the y-intercept because it's greater than. So I'm just going to draw these arrows for now because I really only want an overlapping region. Okay, now let me graph the second one, and I'll use a different color to help. Alright, so you can do this by finding the x and y intercepts, but then you can't really do the shading the same way. So what I want to do is I want to put this in slope-intercept form. So I'm going to take my 3x plus 4y less than 12. I'm going to get y by itself. So 4y is less than negative 3x plus 12. So remember, I can't combine that negative 3 and x and the 12, so I put them next to each other. And then we divide everything by 4. Keep your slope, keep reduced fractions, so negative 3/4 x. And 12 divided by 4 is 3. So my slope is negative 3/4, and my y-intercept is 0, 3. Okay, so I'm going to go up 3 and put a point, and then my slope is negative 3/4. So I need to go down 3 and right 4. Okay, and then this is also a dashed line. Okay. All right. And this is less than, so we want to shade below the y-intercept, so that's this side of the line. Okay, so then I look to see where would they overlap, where would the arrows overlap, and that's inside here, so that's the part I'm going to shade. And it doesn't need to be real dark, but just you need to be able to tell where you are shaded. Okay. It would be a good time for you to pause and do the next one on your own, and then check to see that you did it right. Okay, so for my first line, my slope is negative 1/1. And my y-intercept is 0, 2. I scale down again. Okay, so I go to 2, and then I go down 1, right 1. This time this is a solid line. And I really want to make sure it goes all the way through my graph. Okay, it's greater than, so I shade on the side that's above. And again, I'm not going to actually shade till the end, because I'm just going to do arrows. Okay, the next line, you want to put it in slope-intercept form. So subtract 2x from both sides. So you get 4y is less than negative 2x plus 4. Divide everything by 4. Since you're dividing by a positive, it doesn't flip your sign. But negative 2 divided by 4 is 1/2. Reduce your fraction. 4 divided by 4 is 1. So my y-intercept is 1. My slope is 1/2, so up 1, right 2. Okay, so this will be a dashed line. And I want to shade on the side of the line that is below the y-intercept. So here's my y-intercept, so below would be this side. Okay, and I see that my shading is overlapped right here. Okay, so if I asked you to list a point within this region, if I asked you to list a solution, then you could pick any point inside this region that I have shaded in black here. So for example, 1, 2, 3, let's say 4, 4, 0, that point right there, that is a solution. Now you don't have to do this unless it asks you. So it's in the overlapping region. So it should be true for both of my inequalities. So let's see, 0 greater than or equal to negative 4 plus 2. All right, 0 is greater than or equal to negative 2. That is true. 2 times 4 plus 4 times 0. Okay, that's 8, which is not less than 4. Let me check my 1, 2, 3, 4. Well, this is a good idea to check so you make sure that you have done these correct. Hold on just a minute. Okay, sorry about that. I did find my mistake. So it's not a bad idea to check something like this so you know if you did it correctly. I don't know if anybody caught this. If you did, great job. But negative 2 divided by 4 is negative 1/2 x. So I have this green line wrong, which means this shaded part here is also wrong. So I am going to fix that. Oh. I guess I'm just graphing this whole thing over. Okay. So if I go back to the red, that line was correct. I started at 2. I'll go down 1, right 1. And it is a solid line. This is not going great. I apologize that it's taking a little bit longer than I had planned, but it's good to see mistakes. Like I said, I hope some of you caught it. Okay. And it was a greater than, so I'm shading on this side of the line. Alright, now let me try to do this green one right now. So positive 1, and I'm going to go down 1 and right 2. Or I can go up 1 and left 2. Okay. So now let me draw that line. It is a dashed line because it does not have an equal to. Okay? And I want to shade, and it's less than, so I shade on the side of the line that's below my y-intercept. So here's my y-intercept, and I want below, so I'm below. So actually the only part that they have in common, the overlapping part, would be right in here. I'm using yellow so I can still find a point in here. It's a little bit easier to see. Okay, so now let me pick a point in this overlapping region, and we'll check that one, and hopefully this time it's correct. So I'm going to try 6, 1, 2, I'm going to try 6, -3. Okay, so -3 greater than or equal to -6, because when I plug in the 6, it becomes negative. -3 is greater than or equal to -4. That's correct. Okay, 2 times 6 plus 4 times -3 less than 4. So I get 0 less than 4. That is also true. Okay, so that point is part of my solution. All right, now we're ready to do Unit 5, Assignment 8.